Is that audible to all? Just confirm to me. Audible? Our video is clear? Just confirm to me. Yes. Today we are going to discuss about classification of elements and periodic properties. Classification of elements and periodic properties. So look at first classification. So different scientists, they are classified in the different ways. Then each and every classification that we have to discuss. The first classification is Dobereiner triads. Dobereiner triads. According to Dobereiner triads, sir, middle element of atomic mass is equals to arithmetic mean of other two elements of atomic masses. The middle atomic mass, middle element of atomic mass, middle element of atomic mass is arithmetic mean of atomic mass of other two elements. For example, if you take lithium, sodium, potassium. Lithium, sodium, potassium, if you take. Lithium atomic mass is 7. Then sodium atomic mass is 23. Then this is 39. So now atomic mass of middle element, that is sodium, it is equals to arithmetic mean of other two elements I told. So 7 plus 39 divided by 2. Then 7 plus 39, how much? 46. So 46 divided by 2, how much? 23. So other two elements atomic mass arithmetic mean if you take, then you can get the middle element atomic mass. So these are Dobereiner triads. So such type of elements of the examples, some other examples if you take, then example number 2, this is example number 1. Then example number 2, if you take calcium, strontium and barium. Then third example, that is chlorine, bromine, iodine. Then one more example for the Dobereiner triads, phosphorus, arsenic, antimony. So these are the examples you have to remember for the Dobereiner triads. So Dobereiner triads, so these three elements are in one group according to Dobereiner. So three elements, how they are arranged, based on the atomic masses. Based on atomic masses, he arranged. Based on atomic masses. So how they are arranged? Then arithmetic mean of two other elements is equals to middle element of atomic mass. So like that. So first classification is done. Then the second classification, if you see, Newlands of Octaves. Newlands of Octaves. Second classification, that is Newlands of Octaves. Newlands of Octaves. Sir, what is the Newlands of Octaves? So octaves nothing but 8. The Newlands, according to him, sir, according to Indian musical notes, sir, Indian musical notes such as sa, re, ga, ma, pa, dha, ni, then again sa. So look at, sir, sa after seventh, 1, 2, 3, 4, 5, 6, 7. Sir, again sa will come. Sir, even here also, so every eighth element, when the elements are arranged in their atomic masses, increasing order of atomic masses. So even here also based on atomic masses. Based on atomic masses. When the elements are arranged in the increasing order of their atomic masses, every eighth element is similar to the similar properties of the first element. Similar properties of the first element. See, look at one of the example for that. One of the example: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. At the time of Newlands, there is no noble gases. So now again, so neon after, then a higher atomic mass, sodium will come. So sodium. So here, eighth element, that is Sa, so sodium will come under the Sa, sodium in sodium. So next sodium after, if you take magnesium, then aluminum, then silicon, phosphorus, sulfur, chlorine, then after there is no argon, then potassium. So look at, so all these three, so lithium, sodium, potassium are in one group. So one group. Remember, all these are having the similar properties according to him. Similar properties. Then even these are the similar properties. According to him. So every eighth element, it will be repeat the chemical properties. For example, if you look at Re. So Re again. So look at, from the here onwards, if you take 1, so beryllium 1, 2, 3, 4, 5, 6, then 7, 8. So every eighth element having the similar properties. So like this. So even Ga, from the Ga onwards, if you take 1, 2, 3, 4, 5, then 6, 7, 8. So every eighth element having the similar properties for this. So these are the Newlands of octaves. These are arranged according to or based on the atomic masses only, based on Indian musical notes such as Sarigama Padanisa. Sir, Sa again will come as a seventh, eighth note. So same like that, even the elements of every eighth element, when the repeating periodic properties. So same properties, lithium, sodium, potassium, if you take, all are having the same properties. What are those? All are alkali metals, right? So it is one of the same property. So next, third classification, if you take. Third classification. So what is the third classification that we have to discuss? The third classification is Lother-Meyer curves. Lother-Meyer curves. This is the third classification. So this is also called as Lother-Meyer classification. So according to him, what? Sir, he taken the graphs or curves. So graphs in between atomic volume versus atomic masses. 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 So look at, for example, if you take, so here, this is atomic volume, then atomic mass. Atomic mass. If you draw the graphs in between the atomic volumes and atomic masses, then he can get a curves like this. He can get a curves like this. He can get a curves like this. So remember, these curves are indicating, look at every curve, every peak of the curve, like this. So three main important points we'll discuss on it. The elements which similar properties are occupies similar positions. Elements, first point, look at, I will write here, elements, similar properties occupies similar positions it can occupies. Number two, then every peak of the curve, the elements that occupies then alkali metals. Every peak of the curves, peak of the curve occupies alkali metals. For example, this is the lithium, then sodium, then potassium, then rubidium, like this. Then descending in the descending order here, the beryllium, magnesium, then calcium, then the rubidium, so like this. Every descending order, then the similar positions occupies alkaline earth metals. Every peak of descending position occupies alkaline earth metals. Okay, alkaline earth metals. Every ascending, so here where the increasing position will be there, then more electronegative elements like fluorine, then chlorine, then the bromine, so like this, fluorine, chlorine, bromine. So every increasing position, that is descending position, this is ascending position. Every ascending position occupies more electronegative atoms, such as halogens. So which are occupying the similar positions that are similar properties. It contains the similar properties. So this is Lather-Meyer curves or Lather-Meyer classification. Just note down all these classifications. Yes, sir. Next classification, what will be there? That we'll discuss. This is what Lather-Meyer classification. How many classifications are done? Then first one, Dobereiner triads. The second one, Newlands of Octaves according to the Indian musical notes is arranged. So all three are there based on their atomic masses only. So next important classification is Mendeleev's periodic classification. Mendeleev's periodic classification. Mendeleev's periodic classification. So look at all of you. Then before modern periodic table, this is the most important periodic classification. So even in this classification, he is arranged based on their atomic masses only. So here, so law of Mendeleev's periodic table, they will ask. So which of the following is correct law of Mendeleev periodic tables? That is the physical and chemical properties. Physical and chemical properties of the elements. Physical and chemical properties of elements are periodic functions of their atomic masses. The physical and chemical properties of the elements are periodic functions of their atomic masses. This is the Mendeleev's periodic law. So what he told, so based on the atomic masses, these are arranged. Remember. So next important point in it, see, arranged at the time of Mendeleev, he arranged 63 known elements. He arranged 63 known elements. So at the Mendeleev's time, so how many elements are there? 63 elements are there. Then first time he's taken periods and groups also. So how many periods and how many groups is taken? That way. Horizontal rows such as called periods, that are 7 periods are there. Vertical columns such as groups. Then groups are present 8 groups. Then including with that 0 group also is present. Remember 8 groups are there. So 0 to 8 are present. Every group is divided into subgroups A and B. Every group is divided into subgroups like A and B. A and B. For example, in case of group number 1, group 1A, 1B. Group number 2, 2A, 2B. Group number 3, 3A, 3B. Like that, subgroups also is present in this classification. So what are the main important points are there in the classification that we'll discuss? First, note it up to there. Okay, clear? Yes, note it. In the Mendeleev periodic law, what is the periodic law we are discussing? Then how he has arranged, first time he's taken that is groups and as well as periods. Then every group it is divided into subgroups. Every group is divided into subgroups. So periods, 7 periods are there, 8 groups are there, including with the 0 to 8 we call it as. Then next, remember similar properties of the elements are arranged in the same group. Similar properties of elements are arranged in same group. So ఒకే గ్రూప్ లో ఉన్నవన్నీ కూడా సార్ సేమ్ సిమిలర్ ప్రాపర్టీస్ ఉంటాయి. దట్ యూ హ్యావ్ టు రిమెంబర్. Then second point, so at the time of whatever the unknown elements are there, they are given the gaps in the periodic table. Periodic table లో కొన్ని గ్యాప్స్ కనిపిస్తాయి మనకు. ఏ పీరియాడిక్ టేబుల్లో? మెండలీవ్స్ పీరియాడిక్ క్లాసిఫికేషన్ లో it will visible some gaps. That gaps are for unknown elements which are not discovered at that time. So he is given gaps. What are those? The main important in this, eka aluminum, then silicon. Sir, aluminum nothing but gallium. Aluminum nothing but gallium. Silicon nothing but germanium. So aluminum after the silicon. So silicon after what elements is discovered in the same group that are given aluminum and silicon. For these elements, they are given gaps in it. Then I told that this classification also based on the atomic masses. So atomic masses increasing order low. Atomic masses of increasing order, these are arranged. So first lower atomic mass containing elements, then after the higher atomic mass of the elements, they are arranged. But sir, some cases these are first they are arranged higher atomic masses, then after lower atomic masses. So that we are calling anomalous pairs. So which of the following are anomalous pairs? Such type of question also they will ask. So remember anomalous pairs. So what are the anomalous pairs? In case if you take cobalt and nickel, it is arranged like this. The cobalt atomic mass if you take, that is 58.9. Then this is 58.7. Remember my dear students. So look at cobalt arrange chesin tarvata nickel arrange chesaru. But actually according to Mendeleev's, first should be arranged which is lower atomic mass, then after higher atomic mass, right? But here cobalt after nickel they are arranged. Sir, here decreasing order it will be there, 58.9 or 58.7. So such type of properties we are calling anomalous properties. Then one more we can observe, that is calcium, potassium, calcium if you take. Potassium and calcium if you take. The potassium 39 then calcium 40 is the atomic mass. These also, sorry, calcium, potassium, argon, potassium. Argon, potassium is arranged. Argon is 40, potassium is 39. Argon 40 atomic mass, potassium is 39. 39. So these elements also arranged in the decreasing order. So these two pairs are, which are cobalt and nickel, then argon and potassium, these are anomalous pairs in the Mendeleev's periodic classification. Let's note it, all of you. Then we'll discuss modern periodic law. Yes, look at next classification. Modern periodic classification or modern periodic law. It's modern periodic law. Modern periodic law. So what is the modern periodic law? The physical and chemical properties of the physical and chemical properties of elements or periodic functions of their atomic masses. Atomic numbers, not atomic masses, atomic numbers. So this is the most important nowadays we are discussing about it. So this is given by Mosley's experiment. Sir, what he did the experiment, So high metal targets is bombarded with, all the metal elements are bombarded with X-rays, the suitable frequency of X-rays. Their atomic numbers are increases, then frequency of X-rays also increases. So is given by Mosley the statement that is the square root of frequency of X-rays is directly proportional to atomic number. This is given. This is very, very important. Sir, here based on this is given the relation, that is the frequency of square root of frequency of X-rays is equals to, sir, A into Z minus B. This is the relation is given. So here What is the nu? Nu, it is equals to frequency of X-rays. Frequency of X-rays. Then A and B are constants. Z is atomic number of element. Z is atomic number of element. Atomic number of element. Atomic number of element. Atomic number of element. So here, based on one of the experiment I told, so for each and every element, he passed that X-rays through them. Then once atomic number increases, the frequency of X-rays also increases. So he take a graph for them. Atomic numbers versus frequency of X-rays. He's taken one of the graph in between frequency of X-rays versus atomic number. So how it is taken? So frequent X-rays ni elements mida. For example, here beryllium element is there. X-rays ni increase chesam. X-rays ni pass chesam. Then X-rays ni pass chesinappudu deeni frequency find out chesam. Then other next beryllium after whatever the elements are there. Boron. So boron element తీసుకొని దాని మీద X-rays pass చేసాం. Then every atomic number increases, the frequency of X-rays also increases. So based on that, he's taken, that is frequency of X-rays versus frequency. This is frequency. This is an atomic number. He's taken atomic number, that is Z. Then he get a straight line like this. So what happens there? For every element, then atomic number increases, frequency of X-rays also increases. This is the graph for them. So based on this graph, is arranged. So all the elements are arranged in the particular manner, that is, sir, in the horizontal rows, then vertical columns. So like Mendeleev's periodic law. Horizontal rows that we call periods. So how many periods are there in the modern periodic law? This is the modern periodic law, right? Modern periodic table, if we take. So how many periods are there? 7 periods are there. Then vertical columns that are groups we call. Then groups, how many groups are there? 18 groups are there. How many groups? 18 groups are there. So 7 rows, 18 vertical columns are there. So 7 periods, 18 vertical columns, that are groups are present. So even here also they are told that then which are similar properties of the elements are present that are arranged in the same group. So once if you take the modern periodic table, if you take, see how the modern periodic table is there. I told that 7 periods are present, 18 groups. 7 periods and 18 groups. Then first period, then the second period, then third period, fourth, fifth, then 6th, then 7th period. Okay, clear? Groups 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 groups are present. So like this. So observe it carefully. So 18 groups are present, then 7 periods are present. In the first group of elements, if you take hydrogen, the lithium, sodium, potassium, rubidium, cesium, then strontium is arranged like this. Hydrogen, lithium, sodium, potassium, rubidium. All these are alkali metals. The same group of elements having the same physical and chemical properties according to modern periodic law. So next, in case if we take second group of elements. So in the second group, the first period only hydrogen atom is there. Only 2 elements actually first period. Then the second period if we take lithium after sodium, the lithium after here, beryllium, then magnesium, then calcium, then strontium, then barium, then radium. You can get like this. Beryllium, magnesium, calcium, strontium, barium, radium. Like this. So next, from the group 3, if we take group 3, it will be start from the calcium onwards here. And calcium atomic number 20, then after 21 scandium like this. So here there is no elements up to there. So ante fourth period variki, third period variki emi elements undavu. Clear? Yes. Then this is third group. Next fourth group if it is scandium, titanium, then vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So 10 elements are arranged like this. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So up to 10. So from the here onwards 10. So 13 onwards 10. 3 onwards 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to the 12 it is 10. 10 elements. So zinc. Up to the zinc it is arranged like this. Then after 13th group, the beryllium after, in the second period, so look at boron is there, boron, aluminum, then gallium, then indium, then thallium, like this. Then 14th group, if we take 14th group, boron after carbon, silicon, germanium, tin, lead, like this. Then 15th group elements, all these group elements you have to observe that in the first period there is no elements. The second period onwards you can get. Okay, are you getting? Right. From the 15th group, that is carbon after boron, carbon, nitrogen, phosphorus, arsenic, antimony, then bismuth. Next, if you take in the 16th group, then nitrogen after oxygen, sulfur, selenium, then tellurium, then polonium, like this. Then the 17th group, that is fluorine, chlorine, bromine, then iodine, then astatine, 80. So all these are 17th group elements. We call it the halogens. Halo, nothing but sea, samudram. So అందులో నుంచి ప్రొడ్యూస్ అయ్యాయి. Then 18th group elements. Then helium, neon, argon, krypton, xenon, then radon, like this. So look at 18th group, 18 groups are there. So if you observe carefully, then the first period it contains only 2 elements. First period లో ఎన్ని ఎలిమెంట్స్ ఉన్నాయి అంటే 2 ఎలిమెంట్స్ మాత్రమే ఉన్నాయి. So that is what we are calling it as the first period is the smallest period in the modern periodic law because of only 2 elements are present in it. Then here look at the groups wise if you observe that. So from the 13th group. So here scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Then here yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, then palladium, silver, then cadmium, like this. Next lanthanum, hafnium, tantalum, tungsten, osmium, iridium, platinum, lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, arum, then mercury. So look at these are the 13th third group elements. Then these are 4th group, these are 5th group, these are 6th group, these are 7th group, these are 8th, these are 9, these are 10, these are 11, then 12, then again 13th, here it will be start. So based on this, the modern periodic law, it is arranged in then 7 periods, then 18 groups. So generally 7th period we call it as an incomplete period because these elements are still studying. So 7th period of the elements are still studying. So that's what these are. Actually here actinium, it will be start actinium. Then here from here lanthanoids and actinoids. So lanthanoids and actinoids are arranged. So these are the 14 elements at the bottom of periodic table. These are arranged 14 elements. These 14 elements are from cerium to lutetium. Then these 14 elements these are arranged thorium to lawrencium, Lw, lawrencium, like this. So these are we call 4F series of elements. 4F series of elements. These are 5F series of elements. 5F series of elements. So this is modern periodic table actually. Remember, first 2 group of elements. So based on the classification in the modern periodic table, so these all elements are classified into 4 blocks, such as these 2 groups are S block. S block elements. Then the remaining 10 groups we are calling the D block elements. Then the remaining 6 groups we are calling P block elements. These are which are arranged at the bottom of periodic table, that are F block elements. F block elements. F block elements. So all these classification is based on electronic configuration. Electronic configuration. So how the electronic configuration? Valency cell of valency electron, when it is present in which orbital it is present. For example, valency electron, the last electron is present in the s orbital, then s block elements. p orbital, then p block elements. d orbital, then d block elements. f orbital, then f block elements. So last electron, valency electron, outermost electron, so differentiating electron, when it is present in the particular subcell, that is belongs to that block of elements. Clear, all of you? Then the remaining topic, complete classification from S block and P block and D block and F block and periodicity. So all these topics we'll discuss in the evening session from 7 to 8. So thank you. Okay, right.